Can you show us how this would work? If I had a sextant, how am I measuring this?
You're measuring a flat baseline.
Is there different parts of the sextant?
I'm going to mute him.
Right, but we are talking to an audience as well.
Yeah, we're not.
So
exactly.
we're trying.
I'm going to get muted because I've already addressed it.
Let's just say I'm outside and I have a table on a ship. I could use the edge of that table to determine the flat baseline.
No.
Why not?
Because the table's on a ship moving around on the sea. That's why you use the horizon.
But there is no distance requirement to use this. We only have to have a required horizontal base, correct?
Yeah, you look in the horizon mirror, not the table mirror.
Okay. So, like you said, though, is the horizon can be very far away or it can be closer. So there's no.
We are clear that the horizon's not a table.
Right,
I'm clear. I just want to make sure you understand. You understand the horizon isn't a table.
I understand, but the table is a flat plane.
But it's not a horizon, which is what you look at in the sextant in the horizon mirror.
Correct. And that's kind of where I was saying and that's because the distance from a person to the horizon is predominantly flat because the curvature is insignificant at that level.
No, you're using the horizon to establish a flat baseline that could extend thousands of miles beyond the horizon in order to get the GP position of the star so that you can navigate by finding your position with that GP across a circle of equals. My bad, still in the middle of explaining how Earth's flat to you. My bad, just proving Earth's flat to you. My bad.
I'm going to mute him.
If the Earth is a globe, then we would see the sun go down under the horizon. The sun seems to go down under the horizon, therefore the Earth is a globe, affirming the consequent fallacy. If A, then B, B, therefore A. It's a fallacy. You can get ChatGPT to admit to it over and over again. So when you ask me to explain to you why the sun appears to do what it does, it's just not part of my burden. We've already shown that the horizon is not Earth curve. Therefore, the Earth is not a ball of 3959 miles in radius. I'm done.
Okay, can I respond real quick? And then Josh, I'd like you to chime in on this.
Yeah, no problem. Just been listening.
So if I'm looking at your model, there has to be certain things that happen if that model is to be true. And the whole point of looking at it is to say, I see a contradiction with what you're saying over here. So we got most of this debate was taken up with the curvature thing, which is great. I'm glad. And everybody can figure it out. And we should do those experiments without watching videos. I agree, right? But if I say, all right, how do you answer this contradiction? I want to know, because if that is if the phenomena of the sun isn't explained, then that's a problem for flat Earth. And I want to know, how do you get around that? And what's the evidence that you have to refute that?
So what claim have we made about the sun exactly for us to be defending?
I made the claim. I asked the question. I said, okay, because actually, this is a really good, we didn't actually get your claim. How close is the sun and how does it operate on a flat Earth?
Okay, so you can't acquire that information because if you're using the sun to navigate with, as it moves towards the horizon, if you're measuring an angle, and then calculating the distance to the GP beyond the horizon that isn't Earth curve that we've debunked, then that would infer, if you're using the triangle to get the height, that it's moving lower to the ground as it reaches the horizon. Well, obviously that's not the case. The sun isn't getting closer to the ground. You can derive its GP position to navigate with it, but it's not getting closer to the ground. So we don't have a height claim. I don't make a height claim. Meanwhile, Kepler's third law of interplanetary motion would suggest that you have orbits, and those orbits can be used to give you scaling values for a sphere Earth in a sky vacuum with gas not expanding into it, and the sun being at a 93 million mile distance because a guy called Christian Huygens superimposed the R value we debunked measured by Al-Biruni at a geometric limitation at 1.2 times the square root of the observer's height in feet onto Venus. So Christian Huygens assumes that Venus has the same R value because obviously it's a rock in a sky vacuum in an orbital motion that Kepler assumed. And therefore you can give your scaling values to your R assumptions to give you your distance and size of the Sun, all of which we can debunk. So we don't have a size and distance claim for the Sun. You do. This is a burden of proof reversal fallacy. You're the one with the positive claim of size and distance for the Sun, and asking me why it does a not actual size change as it moves through its not actual position in a refracted non-geometric Earth curve world is irrelevant because I don't have a claim about it. You have one about a distance and size to your Sun in a heliocentric model. And given that I've just told you about all the assumptions of an R value imposed by Christian Huygens on Venus with an application of Kepler's third law, how do you justify your distance to your Sun?
I'm just talking about observation, man. That's what I want to know. How does it work on a flat Earth? If the Earth is flat, and I disagree with Patrick's assumption that there's somehow not the phenomena of half the Earth being lit and half the Earth not. I've got friends that live in Australia. We can experiment all the time and go put cameras out our windows and observe how pitch black that it gets in one area without any kind of faint light going on that you would expect if the sun is going away. You have pitch black and you have full daylight on the other side on it, right? So if the flat Earth model is to actually work, the contradiction I'm pointing out is that the sun would have to change angular size throughout the day. And what we observe, what I have observed, it doesn't change angular size, not even one little bit. And anytime we see change in the size, we can ascribe that to glare and the way light operates with the human eye and everything else. But if you take those solar filtered camera lenses and you track it, and you track it for days and days.
I got it the first time. I got it the first time. I'm not deaf.
I'm just about to finish.
Let him finish repeating it. I heard it the first time.
5. That's 6 times you interrupted.
Doesn't matter what I'm saying.
Dave, go ahead and finish.
Shut up.
Second time I've heard it.
Finish, and then
I heard it the first time.
So I'm going to mute him.
Right, but we are talking to an audience as well.
Yeah, we're not.
So
exactly.
we're trying.
I'm going to get muted because I've already addressed it. And he's rinsed and repeated and gone through the motions of saying the exact same thing again. And because he doesn't like me giving the same objection to the same repetition of the same thing, I get muted. So when I'm asked why I have my own show, for my own audience that can hear me speaking because I'm not in control of my own show, yeah, I can still talk to you as an audience and say, what a wanker. So you don't like me objecting to you repeating the same thing I've already overcome? You haven't acknowledged my refutation of it? Just going to be completely ignored? Yeah, that's all right. Stick me on mute. That's why I've got my own show. So that I don't get muted by a host when I object to hearing the same thing repeated without a single acknowledgement of my refutation of it.
It would change angular size throughout the day to the observer if it was a close sun going over a flat Earth. It would, if it doesn't, that's a problem. And I want to know why.
So when it does change angular size, you've already said that it's because of other factors, right? So it's an automatically falsified observation if you do observe a change in angular size.
That's not what I said. Device that can actually show that it does not change in angular size. And that is a major problem for the flat Earth model.
So just address this multiple times. Yeah? Not actual size? Who gives a crap? Meanwhile, his audience can't hear a single word I'm saying.
Have all the answers.
You're not my guru, Patrick. I love you, man, but you're not a guru.
All right, but just think about what you're requiring right now, okay? We have already gotten to the point where you are completely stymied when it comes to showing that there's curvature of any kind. As visual,
I think we disagree with that. I think it was a disagree to disagree.
Yeah, that's going.
Disagree to disagree when it's 2-on-1 and the other guests can't be heard and interject in any way.
I mean, my God, have the tests been done?
Have you done the test, Patrick?
Patrick, have you done the test? Don't know what they're doing, Patrick. By people.
Meanwhile, we're going to filibuster and talk through everything Patrick says with the other guest on mute.
Not done the test myself.
Okay, so how about this? Is information YouTube, warfare a thing that's happening these days?
Yes.
Yeah. So how do we know that what you're seeing and what you're seeing on the videos?
I want a concession though that when we do show, because I'm gonna have to demonstrate the actual math to you. Because when we came into this,
I would love that. By the way,
you got 4.5 seconds before he got interrupted.
But here's the other thing: when you do see angular size change in the sun, which you can observe plainly getting smaller as it moves out of sight, wouldn't you agree that's much more consistent with a small and local sun?
Okay, thank you for. So that's being postulated by Flat Earth, right? That's
Nope.
the theory.
I asked you a question.
Yes. Okay. Yes. Yes. If you can show me that it changes angular size, then that's a point for your side, because
Would it not falsify the notion that it's 93 million miles away and stationary?
well, yeah, because if it's actually changing in size, then I mean, there's probably more questions that have.
There it goes again. Actually changing in size when we're talking about angular size. Meanwhile, I'm muted, can't object, not allowed to interject into this conversation anymore. Talking about actual size changes when it's not actual size, angular.
The sun does not change in angular size.
That's
So that's another experiment that we could do at the
Experiment.
Badlands Media Conference. Okay, Nathan.
So not actual size change. Fourth time.
Change in angular size. Change in
Not
apparent
actual.
size.
Not actual size.
Not actual.
Right.
Perspective.
Yeah, exactly. I'm not saying the sun itself shrinks and expands and changes and turns into gummy bears. I'm saying, from my perspective, I should see the sun vanishing and moving in and becoming big. It would be the same with the moon. It would be the same with a lot of things, right? So we got to test that. And one way to test it is to get a high quality zoom camera with a solar filter mounted on an equatorial mount. And then that way we can track it over a period of days and then see if the sun itself actually changes in angular size.
Actually changes in not actual size. My God.
Sorry.
No worries. Let's
Not
just move on.
actual.
It doesn't matter.
Do you
5 times
know
is
what I
enough.
mean? Does the
I'll
people in
just
the
get
chat
muted
know what
again
I
if I
mean?
try and refute this, or
Josh, do you know what
second
I
attempt to
mean?
refute it's
I
now
know
getting
exactly
currently
what you mean.
talked
It's not a
through.
problem.
Okay,
Even though I've
am I
pointed out
speaking
not
Greek
actual
here?
size is an
This is a
actual
very
size
simple
change.
observation that we could
Obviously,
make.
I'm going to get completely rumpus and talk through.
Yes,
Okay,
you are. Yes, you are.
Yeah, every time I've talked, I have. So why would I expect anything different?
Oh, yeah.
This is me angry.
But
This is me getting angry,
Okay.
right?
No. You're just annoying, and that's just the fact.
Winning.
So
Yeah, it's annoying for people who
winning,
think they're really
winning at
confident
life,
about Earth
Nathan.
being a globe.
Keep telling yourself that, buddy. Josh,
So-
how about you give a shot on this? What do you think about this?
I'm not allowed to
Well-
give it a shot? Oh, right, I was just on mute for 5 minutes.
Well,
Okay,
actually,
Josh.
I just wanted to say, I'll go ahead and concede to Nathan if he wants to go ahead and give
Okay,
it.
excellent.
I thought Nathan had
Excellent.
already answered it 5 times, as
Excellent.
he said.
So the equatorial mount, where does the concept of the equator come from? Do you know?
Go ahead and tell us.
It's your claim. You were talking about how wonderful the equatorial mount is for a flat
No, I'm
Earth. It's
talking
terrible.
about how the equatorial mount has a problem because it would have to rotate on 2 different axes in order for it to work, but it doesn't do that. And we're going to get to it, and I'll put the argument up for people to look for themselves. I want you to answer about the sun. Let's go with the sun. What do you say to that?
Well, I thought we covered it. Why does the not actual size of the sun not change in not actual size as it moves from its not actual position
I
throughout
didn't
the
say
day?
actual size.
My bad. I
That's
was in
not
the
what I
middle of
meant. I
summarizing
didn't
your
mean
position.
actual size.
Obviously, this is me being
Observer.
angry, right? Me being angry, interrupting you. So why does the not actual size of the sun not change in not actual size as it moves from its not actual position? I'm not going to answer that, but I will carry on with asking you if you know where the equator for the equatorial plane has come from for a second time.
Well, it's based on the concept that Earth is a sphere. So there's an equator.
Wrong.
And
How is it derived then from a sphere? Tell me.
I don't know. Tell me.
It-
Why
it
did
would
you
be
make
the
that
parallel
claim then?
side-
Hold
it would be-
on.
it would-
I'm replying to him.
You just asked us to answer it.
He didn't know. I heard his answer. He said he
I don't
didn't know.
I'm not a mathematician. I'm
But
not
you made a
physicist. I'm
claim.
just asking-
My bad. I'm responding to you. You
It's
don't know.
perpendicular
Now I'm
to
responding to you because I do.
axis
You're
of
not going to
rotation,
yield even though he doesn't
Nathan,
know.
The equator is aligned.
No, I'm
perpendicular to the
telling you
axis
that
of
I'm going to
rotation,
show
okay?
you the argument. Okay, it's not. I'm just posing arguments here because I want to know how you guys respond to this stuff. Okay, this was an argument. This was a challenge that was posed by Red's Rhetoric. Once again, he even put a Mavic
Do you want to get him on?
Pro
Get him on.
as a. Oh, I'd love to.
But you don't
but
know what you're talking
I'm
about.
just-
This is your
I'm just
claim.
I just want to put the
Stop
argument.
telling people
okay?
they
You don't know the
I just
argument.
wanna
I'm trying to
know.
address
Let's
it.
have a
I've already
discussion.
tried to
Yeah,
address it, and every
exactly.
time I try and talk, somebody's talking through me. You
Because
don't know
all
where
you're
the
doing is just
equator.
saying the same thing.
Same
over
thing
and
again.
over
Here
and
we
then
go.
trying to
My
strong-arm
God.
people
What is
through
your
level of the
problem?
Conversation. You're not even answering the freaking questions that David has been asking you.
What about the
I mean,
equator? I asked him where the equatorial
see
plane came
that-
from, and
see
he
how the
didn't know.
telescope's
And now
moving?
I'm getting talked through again.
Yeah.
You don't know where the equatorial plane came from, or what the equator's. My bad. I'm never going to get this statement out. Never going to get the statement out.
And
do is they attribute a model to Nathan and me. We have claimed no model. He picked a model that had that in order to watch the star, you have to have 2 axes of rotation. And then he said on his globe model, the axis is only 1 axis of rotation is required. So first of all, I claim no model. Second of all, that is called an affirming the consequent fallacy. It says, okay, we're going to sit here and imagine that we are on a ball rotating. And note that my telescope only has to rotate on 1 axis. The answer to that is, so what? If you did live on a ball, you would be able to measure the curvature of that ball. If you did rotate at 1,037 miles per hour at the equator, there would be a million different ways that you could verify that. You'd notice. You'd be able to get up in a hot air balloon and then just wait for the Earth to move under you and go there. You have flight times completely different from going east to west and west to east. This affirming the consequent fallacy that you just played for me it's literally proof of nothing. All right, Josh.
Yeah, no, Patrick, you said there's 1,000 different ways to prove if we were on a curved Earth, there's 1,000 different ways to prove it. Give us some of those, and let's have us and the audience and all of us go test that. Because if that's false, right? If the Earth is not curved, and you said there's 1,000 different ways to test that if we were on a flat Earth, then we will be able to find out for ourselves by doing those tests. I mean, does that make sense?
Okay, I've already said the tests, so just to see if I got through.
Okay, go ahead.
Why don't you tell me what such a test would look like? Because I've already explained how one would test such.
Well, maybe I missed that part. Maybe I was going to.
It's literally the entire 2 hours we've been talking about it.
Oh, you're referring to curvature, right?
I am.
Start off with that.
Okay. Well, why don't we just say this? Let's propose certain tests to each other, right? I don't think that we're ever going to come to any agreement on this conversation discussion. I think we can all understand that, right? And look, I'm open to new ideas and concepts. I'm here to learn on this planet, right? I'm here to expand in knowledge. And so what I would like is, if the Earth is flat, great, prove it to me. And the same thing with you. If the Earth is curved, great, prove it to you, right? I mean, this is kind of where we're at. And so let's propose. You guys come to us and say, okay, we'll test this. I don't want to test that the Earth is curved. I want to test that the Earth is flat. How would I do that?
Celestial
Give me
navigation.
those experiments.
With
What's that,
celestial
Nathan?
navigation.
With celestial, as you explained before, taking the sextant to the horizon. But I'd already said this, but we're talking about 69 miles, 75 miles that we have 1 degree of curve. So curve is negligent at shorter distances. So it's going to appear horizontal. That was my argument. Whether we'll measure the angle of the sun in the sky and we'll come up we'll see what we can do, right? These are things that we can do instead of going back and forth. I mean, Patrick, you said there's no model for flat Earth, or that you claim no model for flat Earth. The same thing with you, Nathan. And I completely understand that. I don't want to sit here and try to break down a flat Earth model when you guys don't have a model. But my question is that if we're going to claim that the Earth is flat, how do I know this? And it can't come about through debunking curved Earth. Does that make sense?
Because all of the maps and models that you use, including a globe, were made using flat Earth elevation angle measurements to Polaris. Without exception, your globe model included, they're all flat. They're all derived from flat measurements. The same flat measurements that you use to navigate. That's an elevation angle measurement off a flat baseline. When you describe the 1 degree for every 60 nautical miles, that's 1 degree of declination of the star in your sextant, not 1 degree of a curved Earth. You're measuring.
Well, I'm actually, Patrick.
My bad.
Nathan.
My bad. I'm just answering your question after a long, prolonged request for us to prove the flat Earth to you. I'm just answering that. Not lots of waffle and prefacing. Just answering
on what I said, so I wanted to correct that. If that's okay. Is that okay to do that? If you made an incorrect assumption on what I said, I took the circumference of the Earth, divide by 360, you get 69 miles. I was given an approximation of about 75 miles. And this equates to 1 degree. If a circle's 360 degrees, I think we can all agree on that. If we divide 360 by the circumference of the Earth, as in the sense of the globe Earth model, we should get 1 degree of arc length. Can we all
Yes.
agree on that? That makes
Yes,
sense.
I can agree that if you beg the
Okay,
question
thank you.
that the surface is a spherical one, that you can get 1 degree of 360. However, in
Perfect, thank you.
practical application, when navigating the surface of the Earth and referencing elevations to sea level, you can measure the declination of stars in the sky based on a flat Earth angle. Yes, I appreciate you can beg the question that means the surface is curving, but you can't get elevation angle measurements from a curved surface.
But see, and so for everybody out there, and so kind of what me and Nathan are saying is I'm not disagreeing with him on the sense of how a sextant works. And I did say that before. Am I correct on that?
That proves Earth's flat then.
No, it does not.
Yes, it does.
What it shows you is that the sextant being used as a local instrument to the horizon is predominantly a flat horizontal plane.
It's incorrect.
That's why that works.
No, you're measuring the GP position of the star, and the angle you have to it beyond the horizon could be several thousand miles.
But that
I'm just
measurement is based
correcting
upon
you.
what?
Is it okay if I correct you?
To the horizon.
No, to the GP of the star. I know you don't like being wrong, but when you measure the flat plane, that's the flat Earth baseline, the elevation angle to the star is beyond the horizon, flat for many thousands of miles, and described in navigation as an area of equal elevation. That's a flat plane beyond the horizon.
So Nathan, can you show me in the sense, if we're talking here, so I don't know if everybody in the audience knows what a sextant is. Okay. Right. Can you show us how this would work? If I had a sextant, how am I measuring this?
You're measuring a flat baseline.
Is there different parts of the sextant? We got an audience here as well, man. Right. So I'm just trying to extrapolate as much information for everybody as possible. Right.
Sextant
Me
is
and you
an-
keep on going back and forth with this.
Maybe the audience knows what a protractor is, and then we can kind of give them an idea that you're measuring an angle using two straight lines.
One of which
Right,
is
and-
acquired by pointing the sextant at the horizon and leveling the tool. If you're on a ship, obviously rocking back and forth,
Correct.
you rock the sextant to get it lined up with the horizon. That is what you do to establish the baseline. That's a flat line
Yes.
to measure an angle. You'll be measuring that baseline, and once you've got it, you can measure the angle to the star. Now, that angle will be minused from 90 and times by 60 to give you the distance to the GP. That's the ground position of the star. That would be, or sun, or moon, or whatever else you're measuring in the sky. That ground position is the position where the sun or star is directly above at that time. Now, your horizon, if you're very low to the ground, might only be a couple of miles away, but you're establishing a horizontal baseline with a ground position below that star. That's a flat Earth. It can only be measured flat. That's what an angle is. There's my flat Earth proof. Not agree to disagree.
Okay.
It's not a claim either. It just is celestial navigation. My claim
So Nathan,
with
let me ask you this.
my claim with celestial navigation is that you cannot acquire an elevation angle measurement for celestial navigation if the Earth has a curved surface. It can only be done, it's a prerequisite that Earth must be flat to perform celestial navigation. I'm not,
Is there a required distance for that horizon to be for this to work? Yes or no?
no.
Oh, so I could do it in my, so if I was, let's just say I'm outside and I have a table on a ship, I could use the edge of that table to determine the flat baseline.
No.
Why not?
Because
not
the
the
table's
horizon.
on a ship moving around on the sea. That's why you use the
if
horizon.
but there is no distance requirement to use this. We only have to have a required horizontal base, correct?
Yeah, you look in the horizon mirror, not the table mirror.
Okay. So, like you said, though, is the horizon can be very far away or it can be closer. So there's no.
We are clear that
distance.
the horizon's not a
determine-
table. I just
Right,
I'm
GP.
clear. I just want to make sure you understand. You understand the horizon isn't a table.
I understand, but the table is a flat plane.
But it's not a horizon, which is what you look at in the sextant in the horizon mirror.
Correct. And that's kind of where I was saying is I agree with you on how the sextant works. But
With
that
a flat
does
plane.
not equate to the Earth being flat.
It can't not
because-
be. It can't measure an angle. If one of the lines is curved, then it wouldn't be an angle, would it?
Well, it's not a precise instrument. It's not
It is.
100,000%.
It's an angle
accurate.
measuring
It's an
device. That's
approximate
pretty precise.
instrument.
Yes, it is. You're wrong.
It's pretty precise. It's
Very.
an approximation.
Yeah, very. It's an
Pretty
angle. It just
precise.
measures angles.
Right. And that's because the distance from a person to the horizon is predominantly flat because the curvature is insignificant at that level.
No, you're using the horizon to establish a flat baseline that could extend thousands of miles beyond the horizon in order to get the GP position of the star so that you can navigate by finding your position with that GP across a circle
give
of
me an
equal. My
example
bad, still
of
in the
the
middle of
horizon
explaining how
extending
Earth's flat
thousands
to
of
you.
miles
My bad, just
measure-
proving Earth's flat to you. My bad.
Don't
A
get
circle,
triggered. I'm
I'll try
asking
again
you
for a third
question through
time.
your own
A
words.
circle of equal elevation. That's a flat circle. No elevation change. Flat.
Anyways. Thank you,
Seriously,
Nathan. I
Josh,
appreciate that.
Josh, we
Okay.
have been here. We have been here. We have been here for 2.5 hours, Josh.